Alrighty guys, so going into Unit 4, now we're starting to compare these different market structures. So just to start out with the different characteristics, we talked about perfect competitions with the last unit, where we have many sellers. They're all selling identical goods, and they have virtually no control over their prices. Alright, with this we could think about farmers, we could think about gas stations. Right, since they're all selling identical goods, the only thing they can really compete on is with prices. Alright, our monopoly, on the other hand, we've got one seller who has a lot of control over prices. Alright, and with that they have a lot of market power. They can make profit in the long run, whereas the perfect competition can't. The reason for that is, in the short run, if a perfect competition is making profit, great. Other firms are going to enter into that market, though, which drives down prices. So in a perfect competition, remember that there's no barriers to entry. I'll put that up here. No barriers to entry. Whereas a monopoly would have high barriers to entry, preventing competitors from entering into this market where they're making profit. If we're looking at the oligopoly here, so what we see is a small group of companies, usually like 3 to 5 companies that control a market. They have a lot of market power. And the kind of interesting thing about these is that they can either compete with each other or they can collude and work together. If they compete against each other, they're undercutting each other on prices, they're trying to beat each other out on quality. But what that leads to is lower profits for everybody. So they can also choose to collude and work together and set their prices higher. If we look at OPEC, it's an oil cartel that does the same thing. They vote each year on what to set their gas prices at. That way they're not constantly undercutting each other. That way they can all make a bigger profit. And then finally, with our monopolistic competition, it's really like a mixture of our monopoly and our perfect competition. So you have a lot of sellers, that's the competition part, but they've got differentiated products. If we look at our streaming services as an example here, right, each streaming service has their own unique product, right? HBO has Game of Thrones, Netflix has Stranger Things, Paramount has the Survivor series. Like they all have their own unique product. They're all in competition with each other, but businesses can enter and exit the market, right? Just like with the perfect competitions. So generally, there's pretty low barriers to entry. And let's hold off on the side conversations. Y'all on doing this, please? All right. Now, if we're looking at the rest of this, so why is demand greater than marginal revenue? Right, this is something that throughout class we were kind of struggling with. It's this idea that when we lower prices, we lower the new and the old prices. Right, so what that means is if I can sell, let's say, a hat for $15, in order to sell more of this product, I'm going to have to lower the price down from $15. If I lower it down to 14, 13, 12, 11, whatever, not only do I have to lower the price of the new goods, but I've got to lower the price of the old units as well. And so for that reason, our demand curve is looking at how much people are buying at each price. But as that price goes down, our marginal revenue is going to go down faster. What that would look like over here, we've got our demand curve, and we've got our marginal revenue, which is going to go down. Eventually, it's going to become negative as well. When we get to that inelastic area where businesses lowering their prices are going to lose them revenue, but the marginal revenue is always going to be lower than the demand there. So what it's asking us here, I'm missing a page. Give me 1 second. So draw demand, marginal revenue, and then the total revenue for an imperfectly competitive market. So we've got our demand and our marginal revenue. You'll notice that this is the point where the marginal revenue goes negative. So if we're looking at our total revenue, what we're going to see is that our total revenue is going up until our marginal revenue starts to go down. If that marginal revenue is how much additional money we're making with each unit, then when that goes negative, our total revenue is going to start to go negative as well. All right, y'all, let's stop talking, please. I'm recording. Yo, we'll stop. Sorry, y'all. If we're looking at these barriers to entry for these imperfectly competitive markets, the three big ones that we're looking at here, first off is startup costs. If we're looking at someone competing with Sam's Club or with Georgia Power, we're looking at them having to invest billions or trillions of dollars in order to get their business off the ground. Sometimes it's government-issued paths to monopolies. That would be like our patents or our copyrights, our trademarks. That's the government allowing a monopoly to happen. And then finally, we have the ownership of resources or geography. If we look at De Beers Diamonds controlling 95% of the diamond mines in the world, it's because every time a new one pops up, they're buying it out. That way they can maintain that monopoly. Now, if we're looking at drawing out this monopoly graph here, let's take a look. All right, we've got a couple different things here. So we've got our demand curve, got our marginal revenue, which again goes down faster than our demand. We've got our marginal cost curve, which again goes down and then it starts to increase. And if this firm's making a profit, then what we're going to see is that that average total cost is going to be less than the revenue. So let's take a look at it right here. We've got a couple different things. First off, we've got our profit maximizing point here. So I'm just going to call this Q1. So we're producing at that point because that's where we're making the most money. That's our profit maximizing point. I'm going to call this P1. Now, if we're looking at selling this good, right, I'm not going to sell it at this price. I'm going to sell it what people are willing to buy it for. So let's call this, let's say $5 and this is $7, right? So this is our profit maximizing point at Q1. All right, but we can raise the price from $5 up to $7 and still sell all of our units. So the profit maximizing point, Mr. Mac, is how we find our starting point, how many units we're going to produce. Then we go up to our demand curve to see, all right, well, how much can we charge them? Now, we can tell that this firm's making a profit because their revenue, $7, is higher than the average total cost. Let's call this $4 right here. Right, so our average total cost is $4. The revenue is $7, so we're making $3 per unit there. So that's our firm making a profit. If we're looking at a firm making a loss, then that average total cost is going to be higher than our revenue. So we've got demand, we've got marginal revenue, we've got our marginal cost curve, and let's say that this is our average total cost curve here. So our profit maximizing point, Mr. Mac, marginal revenue meets marginal cost, call this Q1. If we're looking at the price that we're charging, it would be right here, I'll call this P1. But if we're looking at the average total cost, that average total cost here is higher than the price, we'll call this P2. So if our cost is higher than our revenue, our price, then we're going to be losing money there. So what we're kind of looking at is, where is this demand curve in relation to the cost, right? If our price is lower than our cost, then we're losing money. If our price is higher than our cost, we're making money. All right, and the final piece for this page here, identify the elastic and the inelastic range of the demand curve. So really we could just kind of go straight down the line here. All right, over here we're looking at our elastic range. And remember that our total revenue test tells us that if we have an inelastic demand for a good, if prices go up, revenue goes up. If prices go down, revenue goes down. And so if we're looking at this range right here, this side would be elastic because as I'm lowering my price, yes, my marginal revenue is going down, but it's still positive, right? If we call this $2, $4, $6, $8. So if I sell this first unit at $8, my marginal revenue is $8. If I sell the second unit at $6, my marginal revenue is $4. That's $4 more than I had before. If I sell this unit at $6, my marginal revenue is $8. Sorry, $2. So that's still positive, but once we get to this point right here where lowering our prices makes our marginal revenue go negative, that means that for each additional unit, I'm losing money. My total revenue is going down. So that would be the inelastic range. If there's an inelastic demand for a good, then a business has no incentive to lower their prices because they're losing money. If there's an elastic demand, they do. Think about gas stations, right? By lowering their prices down, their total revenue is going up. Label the quantity where the total revenue is maximized. So that would be right here. That's where our total revenue is at its highest, QTR, total revenue quantity. How is the demand and marginal revenue above different than a perfectly competitive firm? It's because they're separate from one another. In a perfect competition, they're the same because we're selling each unit for the same amount. But since we're selling each unit for different amounts here, as I lower the price of the good, I'm lowering the price of the new and the old, and so that marginal revenue is going to keep dropping until we get to this point where businesses have no longer have an incentive to lower their prices anymore. All right, cool. I'll pause it here.